Using elementary transformations, find the inverse of each of the matrices if it exists. So they are given few matrices. Now we are going to find the inverse of those matrices by using the elementary transformation. So first let us see what is elementary transformation of a matrix. There are 6 operations on a matrix, that is with the help of rows and with the help of columns. Those are known as elementary operation on, or we can call it as elementary transformation. The first thing is interchange of any 2 rows or 2 columns. So you can interchange the first row by second row and second row by first row. That is what here they have written. First row is taken as second row and second row is taken as first row. This can also be applicable for column, like first column can be written as second column can be written as first column. This is what the symbol of interchange of any 2 rows, R1 to R2. The second elementary transformation is multiplication of the elements of any row or column by a non-zero number. You can multiply any row or any column by a number. So here for example they have taken a matrix and in column 3 they have multiplied 1 by 7. So to the column they have multiplied 1 by 7. So here it happens like 1 by 7, 1 by 7. Also you can do it for row wise here, that is R1 tends to KR1. Now the third one is the addition to the elements of any row or column, the corresponding elements of any other row or column multiplied by any non-zero number. It means addition of elements of the first row or any row with the elements of the another row which is multiplied by an element. In this case they have added or subtracted, that is R2 is subtracted with the elements of the first row, that is the first row is multiplied by 2. Next we'll see the definition of invertible matrix. A matrix A is a square matrix of order M. Then there exists another matrix B of the same order such that AB is equal to BA, that is equal to I. I is the identity matrix and the matrix that B is called the inverse of the matrix A. And that B is denoted as A inverse. B equal to A inverse. Usually we'll be writing A inverse equal to I. This is what the definition of invertible matrices. So this is only possible for square matrices, not for the rectangular matrices, because rectangular matrices, when we take it, the product will not exist, because we know the rule for taking the multiplication of 2 matrices, that is number of columns in the first matrix must be equal to the number of rows in the second. Therefore rectangular matrix does not possess inverse matrix. To find the A inverse by using the elementary row operation. Now I am going to use row operation. When I am using the row operation, I am going to write our given square matrix A as A is equal to IA and applying the sequence of row operation on that matrix A is equal to IA till I should make this square matrix A as I, that is equal to, will be obtaining a matrix B. That matrix B will be called as inverse of the matrix A. So this is done with the row operation. The similar process can be done by using the column operation to find the A inverse. In that case we have to write like A is equal to AI, not like A is equal to IA. It should be written like A is equal to AI, and the column operation must be applied till we get is equal to AB, and that B is called the inverse of the matrix A. So once if we start row operation, the row operation only continued, not in the middle we should apply column operation. A 2 by 2 matrix is given to us and asked us to find the inverse of that matrix. We have to do A is equal to IA, and we should bring this A matrix as identity matrix, like I is equal to B into A, and this matrix will give you the inverse of the matrix. So to make this square matrix A identity matrix, we should follow. So a 2 by 2 matrix is there. First step, you should make the first element 1, and the step 2 is make the row 2 first element 0 with the help of row 1, and the step 3 is make this element 1 by dividing the number or whatever it is. Then step 4 is make the first row second element 0 with the help of R2. So follow this rule to obtain the A inverse matrix. So our first question is, they have given matrix 1, minus 1, 2, 3. Now we have to find the inverse of this matrix. So I am writing the matrix A as A is equal to IA. A equal to I is 1, 0, 0, 1 into A. So first step is, you should make the first element 1. Since the matrix itself contains this as 1, I'll move to the step 2. Step 2 is, you should make this element 0 with the help of R1. So with the help of R1, how will you make this element 0? 2 minus 2 will give you 0. So using the elementary operation, I'll write the row 2. This row 2 as R2 minus with the help of R1. So I'll multiply this 1 by 2, so that 2 minus 2 will give you 0. So R2 tends to R2 minus 2R1. So R1 write as it is. Now only change in the R2 matrix. R2 matrix 2 minus 2 into R1 matrix. 2 into 1 is 2. The next element 3, R2 element keep as it is, minus 2 into the element of R1. 2 into minus 1. That is equal to, the same operation must be applied in the RHS side also. So here again I am doing it. R2 keep as it is, minus 2 into R1. 2 into 1. Okay. Next 1 minus 2 into 0. 1 minus 2 into 0 into U. So 1 minus 1, 2 minus 2, 0, 3 minus into minus plus. So 3 plus 2 is 5. That is equal to here 1, 0, 0 minus 2, 1 minus 0, so 1. Next step is, you should make this element 1. So to make this element, I am dividing this row matrix by 5. So while dividing this by 5, it will never get changed. So R2 tends to R2 by 5. Keep R1 as it is, 1 minus 1. Only changes in the R2 on LHS and the RHS side. So 0, 5 by 5, that is equal to 1, 0, minus 2 by 5, 1 by 5. The R2 is divided by 5. Next, so we have made this element 1. The step 4 is, we should make this element 0 with the help of R2 only. So to make this element 0, what we have to do? R1 tends to R1 plus R2. So minus 1 plus 1 will become 0. So if we apply this elementary operation, we'll be getting this as 0. R1 tends to R1 plus R2. So 1 plus 0 minus 1 plus 0, 0, 1. 1 minus 2 by 5, 0 plus 1 by 5. So now we got 1, 0, 0, 1 is equal to, take LCM, 5 minus 2 by 5, so 3 by 5, 1 by 5, minus 2 by 5, 1 by 5. So we made it as identity matrix. So I is equal to A inverse A. So now this matrix is the inverse of R matrix A. So 3 by 5, 1 by 5, minus 2 by 5, 1 by 5 is the inverse of the given matrix. So the next problem is 2, 1, 1, 1. Write our given matrix as A is equal to IA. Because I am using the row operation, I will write it A is equal to IA. A is written, identity matrix 1, 0, 0, 1 into A. So first step is you should make this element 1 by dividing the row by 2, or else you can interchange the first row by second row and second row by first row. You can use any one of the elementary operation. So suppose I am using the elementary operation interchanging the rows. I will be getting 1, 1, 2, 1 equal to 1. Sorry, here also we have to replace 0, 1, 1, 0 into E. So the next step is, here we have to make it 0 with the help of R1. So how to make this element 0 with the help of R1? R2 tends to R2 minus 2R1. So 1, 1, 2 minus 2 into 1, 0, 1 minus 2 into 1. So 1 minus 2 is minus 1. That is equal to, same thing should be applied for this also, 1 minus 0, 0 minus 2 into A. Next thing, you should make this element, step 3 is, you should make this element 1. So how will you make that? R2 tends to minus R2. So 1, 1, 0, minus into minus will give you plus 1. That is equal to 0, 1, minus 1 plus 2 into A. The next thing is you should make this element 0 with the help of R2. So R1 tends to R1 minus R2. So 1 minus 0, 1, 1 minus 1, 0. This will be as it is, 1, 0, 1. Here 0 minus into minus plus 1. So it will give you 1. 1 minus 2 minus 1, and this will be as it is, minus 1, 2 into A. Now I have brought this as an identity matrix. So this is our A inverse matrix. The next problem 1, 3, 2, 7. We'll write it as A is equal to IA, since I am doing row operation. A is equal to the identity matrix into A. Step 1 is the row 1 first element must be 1. Since the matrix itself contains 1, I will move to the step 2. Step 2 is you should make the second row first element 0 with the help of R1. So 2 minus 2 will give you 0. So that I am multiplying R1 by 2. That is what done. R2 tends to R2 minus 2R1. Keep R1 as it is. Only the R2 gets changes. 2 minus 2 into 1. 7 minus 3 into 2, and RHS also the same operation should be applied. First row as it is, second row 0 minus 2 into 1, 1 minus 0 into A. Now 1 3 0 1 equal to 1 0 minus 2 1. The next step is you should make this element 1. Since we got this as 1, we'll move to the step 4. Your step 4 is you should make this element 0 with the help of R2. With the help of R2, how will you make it? A 3 minus 3 will give you the 0. Therefore, 3 minus 3, this should be multiplied by 3. R2 must be multiplied by 3. So that is what done here. R1 minus 3 R2. So 1 minus 3 into 0. 3 minus 3 into 1. 0 1. Same thing here. 1 minus 3 into minus 2. 0 minus 3 into 1. Minus 2 1 A. Now apply the operation. 1 3 minus 3 0 0 1, that is equal to 3 minus into minus plus. So 3 into 2 6, 1 plus 6 is 7, 0 minus 3 is minus 3, minus 2 1. So minus 2 1 A. That is A inverse is, we have got like I is equal to A inverse A. Therefore this is our A inverse matrix. Okay. Fourth one, 2 3 5 7. This is the matrix they have given. A is equal to IA. I am writing it. A matrix, that is equal to identity matrix into A. The step 1 is you should make the first element 1. By dividing the same element, I will make it 1. R1 by 2. That is 2 by 2 will give you 1. So I am dividing the whole row by 2. So R1 tends to R1 by 2. 2 by 2, 3 by 2. Same thing applied in the RHS also. 1 by 2, 0 by 2. The next step is, so we got it like 1, 3 by 2, 5, 7, 1 by 2, 0, 0, 1. Next step is, you should make this element 0. Second row, first element 0 with the help of R1. So with the help of R1, how will you make this 5, 0? 5 minus 5 will give you 0. So that I am multiplying our R1 by 5. So R2 tends to R2 minus 5 R1. R2 minus 5 R1. So keep R1 as it is, 1 3 by 2. Now R2 5 minus 5 into 1. 7 minus 5 into 3 by 2. Same thing applied in the RHS. 1 by 2 0 is kept as it is. R2 is getting changed. 0 minus 5 into 1 by 2. 1 minus 5 into 0 into A. Next 1 3 by 2. 5 minus 5 0. 7 minus 15 by 2. 1 by 2 0. Minus 5 by 2 1. Now solve this. I'll get it 14 minus 15 by 2. So minus 1 by 2. 1 3 by 2 0 minus 1 by 2 equal to 1 by 2 0 minus 5 by 2 1. So what is the next step? The next step is you should make this element 1. How will you make this element 1? R2 tends to multiply this by minus 2. If I multiply here minus 2, minus into minus plus 2, 2 by 2 will get cancelled, it will become 1. So minus 2 R2. So this is the next operation. 1 3 by 2, 0 by 0 into minus 2. Here 3 by 2, minus 1 by 2 into minus 2. So next thing, 2 0. Here minus 5 by 2 into minus 2. 1 into minus 2. The next step 1 3 by 2 0. We made it 1. Here by solving it 1 by 2 0. 2 will get cancelled. Minus into minus plus. So plus 5. 1 into minus 2 is minus 2. The step 4 is we have to make this 3 by 2 0. So how to make this 3 by 2 0? Multiply this R1 by 3 by 2 and subtract it, will get the 0. So what is the binary operation? R1 minus 3 by 2 into R2. R1 minus 3 by 2 into R2 will give this element 0. So 1 minus 0 into 3 by 2. 3 by 2 minus 3 by 2 into 1. R2 remains as it is 0, 1. Same thing applied in the RHS. 1 by 2 minus 3 by 2 into 5. 0 minus 2 into 3 by 2. 5 minus 2 is kept as it is. 1 0 0 1. Now take the LCM. 1 minus 15 by 2. 0 minus into minus plus 6 by 2. So 1 0 0 1. 1 minus 15 is minus 14. Minus 14 by 2 is minus 7. 6 by 2 is 3. 5 minus 2. Therefore, I is equal to A inverse A, or A inverse matrix is minus 7, 3, 5, minus 2.